We made a difference. We made it together. We made it. Today we are going to discuss a specific type of structure, bridges. Bridges are incredible engineering feats. They safely connect one place to another. They can span short distances or vast distances over all sorts of obstacles like water, highways, railways, cannons, valleys, and ravines. Shapes play an important role in building structures. The shapes used will determine how strong and stable your structure will be. Engineers learned long ago that when they need a light, strong, and rigid structure, nothing beats a triangle. The two main forces that act on structures are the force of tension and the force of compression. Tension is a force that tries to pull apart a material, kind of like stretching something, whereas compression is a force that tries to push the material together, like you're squishing it. There are many different types of bridges, and each one serves a purpose and has a specific form. Beam bridges consist of a horizontal beam supported at each end by piers. The weight of the beam pushes straight down on the piers. The farther apart the piers, the weaker the beam becomes. This is why beam bridges rarely span more than 250 feet. When something pushes down on the beam bends downward. Its top edge is pushed together, making it compress, and its bottom edge is pulled apart, making tension. Truss bridges. Truss bridges consist of an assembly of triangles. They are commonly made from a series of straight steel bars. The type of force each member experiences depends on the way the triangle faces. For example, we have a Pratt truss bridge. Most of the top members are under compression, and the diagonals and the bottom members are under tension. Truss bridges can span generally up to 350 feet. Arch bridges. An arch bridge is a curved shape with abutments at each end. The arch is what makes the bridge strong. It allows the load to spread out instead of pushing straight down. The load spreads out the abutments, which act as a support on the ground at both ends. Spreading the load prevents the arch from breaking apart. Arch bridges can span from 200 to 800 feet. Suspension bridges. Suspension bridges are suspended from two kinds of cables, major and minor suspension cables. Minor suspension cables are vertical cables connected from the major cables to the deck. The bridge is supported from above using tension in the cables and compression in the towers. This type of bridge can span 2,000 to 7,000 feet, way farther than the other types of bridges we discussed. In today's challenge, we need your help. Ontario has suddenly been hit by a massive torrential downpour that's washed away all of the bridges in your community. You need to figure out the best way to reconnect the school to the hospital as soon as possible, in case there are any emergencies. There are two routes to the hospital. The first one is the most direct, but it crosses a very wide river, which means it requires a long, narrow bridge that can carry only a few people at a time. The second route is the scenic route, but the bridge only has to cross a small canyon, which means it can be a strong, wide bridge that carries more people across it at once. Choose a type of bridge, either truss, suspension, arch, or beam, and the location that makes the most sense to you. For this challenge, you are only to use the materials given. You may cut or bend the straws in any way you like, but plan carefully because that's all you can use. Keep in mind that a bridge in location A must span 35 centimeters and withstand a weight of at least 50 pennies, approximately 125 grams. A bridge in location B must span 20 centimeters and withstand the weight of at least 100 pennies, approximately 250 grams. Your bridge cannot be attached to the desks. It has to be able to balance a paper cup on it for testing the weight. The materials. This will be all you get. 40 drinking straws, 1 meter of masking tape, scissors, a small paper cup, and 2 desks or chairs spaced 35 or 20 centimeters apart. Good luck!